All right, at this time we've probably gotten done going through the lecture for Chapter 1, and we're going to start taking a look at the problems for Chapter 1, and we'll do this for all the chapters as we go through. For Chapter 1, the first problem we're going to take a look at there is number 21. And the question is, suggest a method, let me pull this down a little bit so you can see it. Suggest a method for separation each of the following mixtures into two components. So you have a beaker that has some sugar and sand in it. You're tasked with trying to figure out what would be the best way to separate those two components. And you can sit there and think about it for a while. Go ahead and pause it before I give you the answer if you want to. But one of the easier ways to do it is understanding some of the properties about sand and sugar. Sugar is soluble in water. You put it in water, stir it around, it'll dissolve. Sand, on the other hand, will not dissolve. So that would be one of the best ways to look at a difference of those two components in a mixture is the sugar will dissolve in water. And then, of course, once you're done with that, you could filter the sand, pour it through a filter. The sand will stay behind, and then you're left with a glass of what looks like water. It's sugar water. And then you can simply just evaporate the water. And then you'd be left with the sugar in a separate beaker. Easiest way. All right, the next one, I guess I'll label these off as part A and B. For part B, the way you could separate those two guys out is for oil and vinegar. Oil is something that doesn't mix well with water. Vinegar is a water solution. There's a percentage of acetic acid, which is vinegar, that's in the water. So the easiest way to separate those two components would be just having the container. The oil is going to be lighter, less dense, less heavy, and it's going to float above the vinegar. If you have something called a separatory funnel, which we probably would not have, you could use that to do a nice easy separation, or you could do a variety of ways to skim off the oil off the top and separate them out that way. So we can say that oil will, we'll call it just float on the vinegar. Vinegar. And then you can just skim off or separate. And this is going to be based on polarity, and density. The two are separate from each other. All right, next one, a little bit longer of a question here. In the process of attempting to characterize the substance, a chemist makes the following observations. The substance is silvery white. It's a lustrous metal, it's shiny. It melts at 649 degrees Celsius and it boils at 1105. Its density is 20 degrees Celsius. It's got at 20 degrees Celsius, is 1.738 grams per centimeter cubed. A lot of information. The substance burns in air. It produces an intense white light when it burns. It reacts with chlorine to give a brittle, solid substance. The substance can be pounded into thin sheets and drawn into wire. It's a good conductor of electricity. Which of these characteristics that we listed above here are physical characteristics and which ones are chemical? All right, so the way we want to think about this is physical characteristics are ones that we can observe, we can test them, and it doesn't change what the substance actually is. So it's this metal, whatever it is. Chemical properties are things that we observe, and when we go through the observation process, we will have changed what the substance is. In other words, it burns, and after it burns, it's turned into something else. So that's kind of how we can characterize them. So when we look at these two things, we can make a list, and we'll put chemical stuff over here on the left-hand side, and think of things based on this list, things that are chemical. In other words, after I observe it, it's something different. And the way I can look at these descriptive items is I see the burning one, so it burns in air. And after I observe that burning in air, it is something different. It's no longer this metal. Okay, so I got that one. I look for something else that looks like a chemical reaction or something. And I see that right in there. It reacts. So that's another one. Reacts with chlorine. Okay? And that's actually the end of the list. That's the only ones we have. Everything else on this list is considered physical. And if we want to take a look at these and say, okay, which ones would that be? Well, it's silvery white. All right. It melts. I'm not going to put the whole thing down, but it melts at some temperature. It boils at some temperature. Another one we had on there was, I think it has a density. That is a physical characterization. And we see about the whole pounding it out. That is a malleable, being able to pound a metal into thin sheets. And it says something about ductile or something, I don't know. Then one last thing on there, which is a physical characterization, is it is a good conductor. That's one that maybe we confuse. And the way to think about it is after electricity goes through this material, is it something new? No, still the same thing. Copper wire. Copper is a really good conductor of electricity. Doesn't change. So that's a physical characterization. Okay, that one is done. Let's look at one more for this particular screencast. 25. Make the following conversions. You got 72 degrees Fahrenheit. We want to turn it into Celsius. Okay, so we've got a couple formulas we can fool around with here. One is if you're given a Fahrenheit, so I've got some Fahrenheit type temperature thing. The little formula, which, outside of this chapter, we'll never ever ask you to do this again, but it's fun to know in your everyday life. Who doesn't want to know how to change Fahrenheit into Celsius? All right, you've got some Fahrenheit temperature, and the first thing I would do is subtract 32 degrees from whatever it is. The next thing, according to the best math practice, is to multiply times 5 and divide by 9. And that will give you an answer in degrees Celsius. So for example, the first one on there was the whole 72 degrees thing. To get an answer for that one, just plug it into that formula, and 72 degrees will turn into 22 degrees Celsius. I'm not going to run through the whole shebang on that. Now doing the opposite one, if you're given 216.7 degrees Celsius, you have to turn it to Fahrenheit, you just have to flip it around. So what I would do for that one, starting with this number, is I would add the 32 degrees. And given that, then I would multiply times 9 and divide by 5. Whoops, I just said that one wrong. Given this Celsius temperature, the way we would do that one, and let me just kind of put that on here, degrees Celsius, the first thing we do, according to the rules, please excuse my dear Aunt Sally, is we would multiply times 9, divide by 5, and then add 32 degrees, and that'll be equal to our Fahrenheit temperature. Easiest way to do that one. Okay, there's one more formula for, I didn't give you the answer for that. For part B, the answer should be ballpark 420 degrees Fahrenheit. All right, part C, we have a Celsius to a Kelvin temperature that we're taking a look at for that one. And the way we would go through that one is a lot easier. There's not as much math on there at all. Is if you have a Celsius temperature and you want a Kelvin, all you got to do is add 273 to it, and you will have an answer in Kelvin. And of course, just the opposite. If you have a Kelvin temperature, you would subtract 273, and you will have an answer that is in Celsius. And just to throw the last bit of answers out to you, for part C, your answer should be 506-ish Kelvin. For part D, and again, I'm just skipping through to the answers for these. For part D, the answer should be 100 108 degrees Fahrenheit. For part E, given 2500 Fahrenheit, your answer should come out to be 1600 Kelvin. And then for part F, it should be negative 460. And again, for those, Kelvin cannot be negative, which we talked about in the lecture. Kelvin goes all the way down to 0, and that's the end of it. All right, that's a good place to end for this first lecture.